All righty, the tunes. Hello, everyone, and welcome to another exciting workshop hosted by us here at Circuit Stream. This one, I myself am super excited for, especially considering it's on the artistic and 3D side of things. But before I do continue on, please let me know in the chat. It looks like some of you have already commented there, but can you hear me and see me? I hate to continue on without anyone being able to hear me. So let me know. Give me a yes if you can hear me. Selena, I can hear. Wonderful. Lynn as well. Roger, thank you everyone for letting me know. Um, it's a great workshop we've got going on here. As with all of our workshops and webinars, I would like to ask the question, especially since it is Thanksgiving in the US, where are you all currently tuning in from? So I myself am located in Calgary, Canada. Our headquarters are based out of Calgary in Canada as well, though I have colleagues backstage from Toronto and all over North America here. So I see some from the US, San Fran, UK, India. We have Warren as well from the US, some more from the UK, Ohio, Berlin, Seattle, London, Kansas City, Sydney. I hope this is Australia. There might be another city, Sydney, considering that there's two Calgarys in North America, I believe. Aussie, yes, wonderful. So with that, for you Americans, happy Thanksgiving. I hope you have all had a wonderful dinner with the family or spent time with your loved ones there. Now, without further ado, I'll just do some quick housekeeping items here. As you can see to the right, there's a chat there. Feel free to chat amongst yourselves. Toss in your LinkedIn profiles, network with each other, whatever it may be. Beside the chat tab, there is a questions tab. If you have any questions throughout this presentation, please toss them into the questions tab. It allows us to easier track what hasn't been answered for that in-depth Q&A session at the very end of this workshop. Now, beside the questions tab, there is also a polls tab. So I'll be tossing in a few polls in this presentation and throughout the workshop just to gauge your experience level. So for Tyrell, who will be joining us later for the XR effects with shaders portion, he will be able to actually see, okay, these guys are experienced. We'll get going through the stuff quicker. If they're more beginners, he'll take his time explaining some other things there. But as I said, backstage, we have Kyle, we have my colleague Vlad, Dayon, a few other colleagues as well, Jerry. So say hi there from Circuit Stream. But, let's get going. Let's get into the nitty gritty. I know Tyrell's got a pretty big part he wants to get covered, so let's get to it. My name is Stefan, and I'm the course lead here at Circuit Stream. So I have over 6 years of experience in the tech industry working with travel IT companies, learning management systems, ERP and business integration platforms, and now in the world of AR, VR, MR, or XR for short. Now, a little icebreaker about myself. I'm sure some of you who've joined our workshops might be tired of this, but I was a member of Water Polo Canada back in 2008. I trained with the 2008 Beijing Olympic team. Great experience. Nonetheless, I didn't go to the Olympics, but I loved my time there and learned a lot. Today, I will be joined by Tyrell Lewin, and Tyrell is our lead instructor here at Circuit Stream. He's also a CTO and co-founder of a couple businesses and companies, but most notably Elucity. So if you have any questions for Tyrell throughout the presentation, throw it into the questions tab. He'll be more than happy to cover those for you. Now, Tyrell has over 5 years of development experience, over 3 years of tech artist AAA gaming experience as well. And an interesting fact, an icebreaker about Tyrell here, he's 6'8", played in the NCAA basketball specifically, and he can solve a Rubik's Cube in 20.42 seconds. And I saw it yesterday with my own eyes. Couldn't believe it. His hands were just going crazy like that, solving it. Maybe he'll show us today. If we're lucky, maybe we'll see him solve something in 20 seconds. Maybe he'll break his record. But now before I dive into the shaders and the effects, a little bit about us at Circuit Stream, who we are, what do we do? Well, Circuit Stream was founded in 2015 when everyone was on those hype trains trying to build VR and AR projects and applications. we noticed the gap in actually helping people learn how to develop and create these experiences. And since then, we've taught over 30,000 people around the world how to create, develop, and manage virtual reality and augmented reality experiences. Now, we're a team of about 20 people from all different backgrounds who have come together now to help promote this technology and industry. And again, headquartered in Calgary, colleagues located all over the world, mainly in North America, South America, but in Asia as well. Now, Circus Stream is a Unity certified training partner, and training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. Now, Circus Stream is also an official channel partner with Unity, and that means we deliver training and application development services in the architecture, engineering and construction, automotive, transportation, and manufacturing markets. So there's three things we really do here at Circus Stream, but what we're most focused on, our bread and butter, is education and training. And these are just some of the students and companies that we've had the pleasure to teach and help develop and manage these AR and VR projects through our courses. From Apple, Hulu, the US Navy, Deloitte, various universities and colleges around North America, Hershey's, the chocolate company, and you best believe that chocolate is going to be super tasty after they work and build out whatever they're doing with VR and AR, mainly improving the processes for creating these chocolates there. Now, we typically do this through two courses that we have. We have our beginner-friendly XR development with Unity course, 10 weeks long, 4 hours of instruction per week, with a next course set to begin on February 15th. Now, we have an advanced course, quote unquote, which is called our XR Project Accelerator Program. And it's 8 weeks long, 6 hours a week, and our next course begins on January 5th. Now, what differentiates us from some of the other providers out there? Well, it's our one-on-one support and mentorship, where we help you build out your own projects and ideas in our programs to add to your portfolio, to prototype, to show to friends, family, whatever it may be. Privately, one-on-one, guiding you, giving you the best practices, and supporting you any way we can. Now, we do also have a bunch of shorter courses for those who don't want to get into depth of AR and VR. So feel free to check them out. They range from C#, 3D art, HoloLens, Quest, Unreal development, you name it. Check it out on our website later on, whenever you get a chance. Maybe there's something there specifically that would interest you. Now, the second thing alongside education and training that Circus Stream does is content creation. So all of our instructors are also developers working with companies around North America to build them VR and AR projects. And these are some of our current clients that we're very happy to be working with. Now, the third thing alongside education and training, as well as content creation, is the Circus Stream platform. And essentially, it just allows people to host their projects and applications on, scale, distribute, and manage those projects, as well as to track, measure, and analyze learning activities. So if I build an app for my family in Europe, I just go onto the platform, put my project there, send them the link, give them access. Now they can play with what I created from the comfort of their own home in Europe. So now that you've learned a little bit about us and what we do here at Circus Stream, what are you going to learn today? Well, today you're going to learn why shaders are important, how they work, and how to work with them. You'll also be learning the understanding and the fundamental elements essentially used in almost every shader. We'll cover how to conceptualize, design, test, and implement effects with the shader graph, and how other designers can interact with your shader outside of the graph editor. Now, I'm going to toss in a poll here. So go to the polls tab just quickly. I'm going to put it in here. I'd like to know, on a scale of 0 to 10, how much 3D experience do you have? 0 being no, never heard of 3D, 0 experience, never played with it. 10 being that, you know, you're a Jedi master of 3D. So I'm just taking a look at the results here, and it's quite spread out, to be honest. There's it looks like it's a good balance between beginners and advanced learners. I would say there's probably more advanced people in the audience today. So this will be very good for us to know, for Tyrell to know, to dive into the shading aspects and the effects aspects later on. So with that, I do also want to ask, for those of you who are joining us today, how much Unity experience do you have on a scale of 0 to 10? So this is another poll I just tossed in. Check out the polls tab. Just to gauge, some people might have used some 3D softwares and never touched the Unity. So just curious to see what that looks like here. I'm looking at the results. Again, fairly even balance, I'd say. We have a couple of 10s and 9s here in the audience for Unity experience. We've got a few 0s, some beginners as well, but a good even spread for both Unity and 3D. Very interesting. Very interesting. We're going to see how this plays out. But for those of you who said 0, what is Unity? Well, Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. Now, XR, for those of you who are new to this, is an umbrella term for AR and VR. XR stands for extended reality, AR, VR, augmented reality, and virtual reality. Essentially just capturing all of those under one term there. And how does one actually go about, creating their own VR, AR project? Well, you have an idea, you bring it into a creation engine like Unity, you build it out, you optimize it, you get it going. Then you use an SDK, which could be the Steam, Microsoft platform, whatever it is, and you push it out to the headset that you want to have it for. So again, idea, created in a creation engine, SDK to headset, and voila. Now, today is about XR effects with shaders. And I would like to take this time to invite my colleague Tyrell onto the stage here. Again, it's a true pleasure and an honor to have Tyrell join us. He's located in BC, so anyone from BC, say hi, give him a shout. But Tyrell, thank you for joining me. It's, again, great to have you here. Really looking forward to this, and you're all in really good hands. Tyrell is going to be taking about 45 minutes or so to go through this piece here. So feel free to toss in any questions you'd like in the questions tab. I will conclude it, 5 minutes, wrap it up, and then Tyrell will rejoin me and we'll get going through those questions there. But you're all in good hands. Tyrell, take it away. Good to see you, and I'll be back shortly.
Awesome. Can you guys hear me well? Sounding good? Awesome. Well, welcome to the Shader Workshop. I will be your DSW for today. I like to stand for Designated Shader Wizard. I'll be taking you through some effects. My goal is to hopefully introduce you guys, but I guess I want to state this off the bat. I'll try to remind you at the end. The goal when introducing shaders, same thing with C# from the beginning and stuff like that, is not necessarily to have you come away like after 40 minutes, you'll be able to walk away and create absolutely any shader completely from scratch, no help at all. I mean, to be honest, today we live in a world surrounded by Google. Trust me, even in the game industry, we spend all the time in tutorials, looking at articles. So it's more about getting you comfortable with shaders, demystifying, not making you so scared of them, making sure that you can go in confidently to a tutorial, watch it, and have an idea of what's going on and be able to understand what they're doing so you can manipulate things to adjust it to your own levels and eventually start working your way up, building more and more of a repertoire so you don't have to go to the tutorials at all and you could still build more and more from scratch on your own. So with that said, give you still a little bit more of an intro on myself. I mean, I've been a math guy my entire life. Loved it. On my recruiting visit, kind of got introduced to a gaming studio and fell in love instead with programming and the idea of becoming a game programmer. And kind of on my own in the middle of university, started looking into more and more effects and started diving into the world of graphics engines and started creating my own. And trust me, when you see creating hundreds and hundreds of lines of code just to get a single triangle to show up on the screen, at that point, you know, you're just tired. You've been looking at code all day, and then they introduce you to a shader. And now all of a sudden that triangle has color, and then it has lighting, and then it has a texture, and it really comes to life. And from that point on, my mind was blown with shaders, and I've loved them ever since. And it's kind of what I did going into the industry. It's how I got into the industry. I was the shader guy, and that's what I did at Hellbent Games, and working through there. And one of the really cool things about shaders is when you work with shaders, you are instantly the coolest guy in the office. You have instant bragging rights, and no matter how much you're kind of doing or not doing in the office, as soon as somebody asks for an effect, you go to make it. And when anybody comes by your desk, it's oohs and ahs, because they're just blown away, because everyone is too afraid to dive into shaders. So hopefully I can help get some of you guys along that track as well. So been talking about shaders. What are shaders? So let me share my screen here. Hopefully you guys can see this well. So what we got here is we have Unity, right? This is the standard Unity project launched with 2020. I haven't touched anything yet. So we have a whole bunch of objects here. So this is the stuff you're used to, a bunch of game objects, you know, some C# components on here, mesh renders and stuff like that. So when you create objects inside of a game engine, you work with C#, you script, and at the end of the day, really what you're doing is you are turning on and off game objects at certain times, moving things around, setting their transforms. You're scripting at a high level. But how that actually gets rendered onto your computer is the game engine takes all of those high-level movements and transform positions and off and ons, and it compiles all of that every frame into a list of vertex information, just a bunch of lists about vertex positions, the colors you want to use, the textures you want to use, packs all of that into tight little arrays of data and sends all of that to the GPU. And then it's your GPU, your graphics processing unit, that's in charge of rendering that to your screen. Well, how does your GPU take a bunch of vertex information and display those to the pixels? Well, it needs to run some sort of program to do that. And the program it runs is a shader. So shaders are literally GPU programs. And so when you can say you're a shader programmer, you can say you're a GPU programmer, which is, I always thought, kind of cool as well. And so one of the beautiful things about shaders is the fact that they're so technical and mathy and stuff like that, but they end up creating very artistic things. At the end of the day, it's for art. It's with the goal of creating colors, with the goal of displaying colors, because that's all you have, right? Your pixels are just that. It's an RGB value. It's just a bunch of little lights, and it's either red, it's green, or it's blue. And the shader is the one that tells it what color it is. So it's pretty cool how it does that. So if there's one major concept want you guys to take away from shaders that I think is usually what makes them really hard to understand, is the kind of free flow of data that they tend to have, in the sense that at one moment you're working with some information inside a shader, and it's basically it's a lot of math, and it's, you know, numbers and floats and signs and adds and power nodes, and then all of a sudden it becomes color, or then now it's position, or wait, this was a direction, and it just kind of flows back and forth so seamlessly. And it's I think that's a concept that can be hard for beginners to understand. Wait, I thought I was working with position. How is this color? So let's actually kind of dive into that now and see what that's like. So in order to create a shader in the new URP, it's pretty simple. All you have to do is right click, go to create, and it's right under C# script. And then you can select your shader graph down here. These were the standard shaders in Unity from before, the standard surface shader. Most of these no longer work, especially the surface shader, no longer work on the new URP, Universal Render Pipeline. So we'll have to stick with these graphs. We will stick with the standard PBR graph. Unlit graph is if you want to do usually a lot of effects, you want to be unlit, so lighting doesn't change it at all. But we're just going to work with the standard PBR graph. PBR stands for physics-based rendering, which is kind of I would say new wave, but it's pretty standard now. It's basically just a way to render objects rather than being reliant on colors. that artists pick out. It's a little bit more relied on physical properties to match real world, to make your environments look a lot more realistic and consistent is the biggest thing. So when I double click on this shader graph, it pops up this window, which is pretty annoying. I don't know what's going on here. So let's just right click on this new tab that got created and maximize it so we can see a little bit better. So what do we have here? We have this graph. I can pan around by clicking in the middle mouse button and dragging around. Keep in mind, some of this stuff is still a little bit work in progress. So if you don't have a mouse with a mouse wheel, I think we found it's a little bit hard to move around because this pan doesn't actually do that. So still working on some things, but for the most part, it's ready to go. It works. So what do we have here? We have this PBR master node that seems to have all these options in here. I think I saw that most of you guys had some 3D art experience. So if that's artist experience, then most of you will have an idea of what this means. You know, the position, normal, maybe not as much, but emission, metallic, smoothness, occlusion. A lot of these things I'm not going to get into today. I want to keep it simple and just focus on what we can do with this albedo, which is the color. And you'll notice that this color matches this preview quite a lot. And that's because that's exactly what it does. Remember, a shader at the end of the day is just a program to tell the GPU. It's kind of the last line of defense that says, this is what I want the color of every one of those pixels to be. This is literally writing to those pixels. So if I click on this and I say I want this to be red, every single pixel in this model becomes red. I want it to be green, yellow, blue. I can make the rainbow, right? And I don't have to do it just from here. This is a node graph. So what I can do is I can click on this little connection, drag it out, and now I can create a new node. So I can just type in color to find a color node, and I can get this basic color. And now I have this node that I can control it from, and I can click on the color here, and I can do the same thing. I can output a different color. So I can basically say, for every pixel, I want to write the color. If we go to RGB 0 to 1, I want to write 0, 1, 0. I want to write pure green into the output pixels, every single pixel. So that's really all we're doing in the shader. All the stuff we're about to do today and create a bunch of nodes, at the end of the day, it's all just going to come right into this albedo property and change the color at the end of the day. So let's take a look at one really important node used a lot for doing textures and stuff like that inside of shaders, which is the UV node. So the UV node is, if I type in UV and just get the basic UV, we get this node right here, kind of this green, yellow, red concoction of something. So what are UVs? Let's actually go back to the scene view, and let's turn off these objects. And I'm just going to create a basic cube, 3D object like that, cube, and reset the transform. So here we have our cube. So this cube's pretty boring, doesn't have a texture on it. So maybe we want to add some sort of texture to it. So how do we go about doing that? Well, usually, if I go, why is that not working? My print screen function is not working. Is light shot running? There we go. Oh, I've never seen that go off before. Okay, here we go. So usually, if we have a cube like this, we want to apply, some sort of texture to it. So say we have some 2D picture that we created in Photoshop of a beautiful smiley face. This is our texture like this. How do we go about applying this texture to the cube so that everywhere on this cube, every face on this cube has our smiley face picture on it like this? How does the computer actually go about doing that? Well, the way it does that is it needs to somehow capture the information about these. So, for example, if the computer can reason that, hey, let's call this bottom left corner 0 and this corner over here 1, and we'll increase from 0 to 1 as we move this direction. Okay. And how about the same thing here? We'll increase from 0 to 1 as we move in this direction. Well, what does this look like? This looks like a graph, like an XY graph, like you're used to in school. Well, we're already using XYZ for position information, so we can't really use XY. That would be confusing. So we'll use U and V instead. And that's all it is. UVs are just basically XY. They're basically coordinates like you're used to, but for 2D textures. And so what that means is now every spot on this texture, we can assign a coordinate to it. So if it increases 0 to 1 this way and 0 to 1 that way in V, then we can say, hey, this left eye is at about 0.4.7 maybe. So the coordinates of that eye is 0.4.7. Maybe this top right mouth, that coordinates are 0.6, 0.4 maybe, something like that. Okay, well, how does that help us with our model? Well, how it helps us is because when a modeler creates a model in a 3D program, they actually, for each one of these vertices, they assign what's known as UV coordinates to it. So a modeler would basically say, hey, the UV coordinate of this vertex is 0, 0. The UV coordinate of this vertex is 0, 1. This one's 1, 0. And this one is 1, 1. And so now we have a direct relation that we can use to map these. So I can say, hey, 0.4.7 is left eye, so let me go to 0.4.7 on my model, and now I can draw an eye. And so that's what the computer is doing. When it goes through scanning the texture like this, left to right, it just looks at the UV coordinates here and maps those to the same UV coordinates there. So let's go ahead and visualize those coordinates. So what happens if I maximize and I say, instead of this color, I don't want to output that color, I want to output the UVs. What does that give us? So if I save this asset, so now we actually have to see as well, how do we apply this shader graph that I called pulse? How do we apply this to the material or to the model? I can't just drag and drop this on. So what I have to do is I actually have to right click and I have to create a material for it. And you'll notice if I right click on the shader itself and create a material from there, it actually assigns that shader to it automatically for me. So if I call this pulse, I now have a material that I can apply to my model. Keep in mind, you can still also go create a material by default, not clicking off in the shader. And I create a material like this. I can then still use this drop down here to look for my shader graph pulse material and still apply it from there as well. Either one will work. Boom, I'll delete that one. So we got this pulse material, and what on earth is going on here? So we see the greens, we see the reds, and okay. So to understand what's going on here, we have to remember kind of what I was saying before, in that data flows and it's represented at any point in time in a different way. So in this case, right now, we're representing UV information as color. Well, how do you supposed to understand this? Well, let's take a look. So how is color represented inside of computers? It's represented most of the time as RGB, right? Where you put a number in here, you have a number here, a number here, and a number here, and that results in a color. Well, let's take a look at what those UVs are again. Remember, the UV coordinates here were 0, 0. The coordinates here were 1 in the first coordinate, which is U or X, and 0 in the second coordinate, which is Y or V. And then this one was 0, 1. This one was 1, 1. Well, if we output this coordinate into a color, because we plugged it straight into our albedo, what do we get? Well, here we get 0, 0, and 0, because the third coordinate that doesn't exist is blue. There is no Z coordinate, so that will just get a value of 0. And so you get black. 0, 0, 0 is black. Well, what's 1, 0, 0? 1, 0, 0 is full red. So in the bottom right corner, we get full red. In the top right corner, what is this? This is 0, 1, 0. Well, that just looks like RGB. That's G. That's green. So we get full green. And this yellow, 1, 1, and 0. If you combine red and green full, you get yellow. So now you can see we're actually visualizing the UV data that used to be numbers as colors. And this is a super cool thing, an important thing that happens all the time in shaders, where we start to visualize data that used to be just numbers and math, and now they're turning into colors that we can use somehow. A typical way that UVs would be used is, for example, if I split this out, if I just add a split node, so I can, rather than looking at the UVs as one whole vector, I can now look at an individual component of it. For example, let's just look at the red channel, or let's just look at the first coordinate, the X's or the U's, if you will. And now what do you get? We get this kind of pattern that is more like a gradient from left to right, where it starts out as black on this side and full white on this side, because as it moves from left to right, the values increase, right? Because it starts out, all of these values, all the UV coordinates of all of these values on the left-hand side are all 0 in X, and all of them over here are 1. So if you output full 0, you get black. Full 1, you get white, and you kind of get the gradient in between. We can do the same thing by looking at the G channel instead. And what would we get? We would get the same thing, but from top to bottom. And so now we can start to create masks, and we can manipulate things based off of where we are in the object. So a lot of shaders will use these UVs to create these different types of masks and move them along. One of the cool things I'll just show really quickly is if I come to this shader and turn it to turn the surface type from opaque to transparent, and then instead of writing this to, let's take a look at the preview. I can also so turn on the preview from here and here. I can right click on here and actually change the default preview to a quad if I want, instead of the sphere, which can be nicer to see for what we're about to do. So we have this color. I can actually output this channel, which remember we saw was just some black and white information, some 0 to 1 values. I can output that to the alpha, and then take a look at that. Now the left side of the object is faded out and the right side is fully opaque, because the alpha controls the transparency of my object. What can I do with that? These are just values. I can create an add node. So if all of these values in here are 0 right here and 1 over here, what happens if I maybe add negative 0.5 to it? So I subtract 0.5 essentially. Well, now the value that used to be 0.5 in the middle is now 0, because we had 0.5, we subtract 0.5, it becomes 0. We had 0 over here, we subtract 0.5, it becomes more negative, so it's super black. And now over here, and we kind of have this shifting effect where we can move this left and right, because the more I subtract, the more it gets black, and the more I add, the more it gets white. What happens if I put that into the alpha now? Well, now we have like a wiping effect, and we can kind of wipe something in, wipe something out. We can change the direction. We can wipe it in and out from top to bottom. So already we can start to manipulate this data that used to be just UV information. Now we're using math to just add to it. And now we're getting an effect, a visual effect, which can be super cool and handy. But I don't want to get too far into alpha today. So let's keep on moving on with the different ways to visualize data. So we've seen UVs, which are super handy in majority of shaders that you will use. We're not going to look into them too much today because we're not going to be working with textures, but they can be a great way to manipulate textures and add distortions or different types of effects like that. If you get comfortable using these masks, separating them out, the red and green channel, and manipulating that data in some way. But what we're going to do instead is continue looking at representing data as colors. So what if I just type in position here? Like I want to get some position information, world space position, for example. If I take a look at this and output this into albedo, what do we get? If I save that asset, unmaximize it, go back to my scene view, what on earth is going on here? Okay, so now we see a whole bunch of multicolor things. Kind of cool, but maybe we don't really know how to work with it. Well, what happens when we move it around? Ooh, some interesting stuff. Okay, let's try moving it to the right. That kind of looks like it's getting a lot more red the further right we move it. Okay, let's put it back at 0. What happens if I move it up? It's pretty green. Move it forward, blue. So maybe you can kind of see what's happening here. But remember, what is the information we're outputting? We're outputting world position. So we're saying, hey, what's the world position of this object? Well, the world position right now is 0 to 0. So it's a lot of values in the Y channel. So all of these vertexes, all of these pixels basically are saying, hey, I have a value of like 0 something in Y 0. So I'm going to be green, right? Or I'm going to be red, or I'm going to be blue, or I'm going to be a negative color. So I'm going to be really dark. I'm going to be black because we have no way of representing a negative color. So now we're visualizing world position in this way. Okay, let's take a look at another cool one. Let's take a look at, instead of position, maybe let's look at normals. If I look at the normal vector, what are normals? Normals are basically the direction that the surface is facing. If I have a sphere here, well, actually, we'll just show you on the cube. So if I unmaximize this, go back to the scene view, we could see what we get here. So basically normal of an object denote the direction that the surface is facing. So if the surface, this pixel, this face is facing that way, so it points straight up, so you get a green. Now this one faces that way, points straight to the right, so you get red. This face faces that way, so you get blue. And all of these faces face that way, right? So all of these pixels here are all blue because they all have the exact same direction. All of these pixels here face straight up, so all of these are green and all have the same direction. Same with these. Well, a cube is pretty simple, maybe a little bit boring. So let's take a look at it on a sphere. So if I hide the cube for a second and throw this on the sphere, you got to get a much more interesting blend, because only at the very top is it pointing straight up. But as you kind of rotate around, it starts to get closer and closer to the right and closer forward. And so you kind of get this cool blending of information here being represented. And of course, when I move this around, that doesn't change it at all because the surface is still pointing in the same way. Okay, so those are the normals. Let's take a look at one more cool one here. Let's take a look at view direction. So view direction is pretty much what it sounds like. It's the direction that the direction towards your view. So if I unmaximize this, if I take a look at the scene view here and getting close, and what happens if I look at this from the right-hand side? You can tell which side I'm at by looking at this compass on the top right. And you can see that over here, if I rotate down here, I'm looking at it from the right, and it starts to appear a lot more red. If I look at it from forward, it starts to appear a lot more blue. Look at it from the top, it looks green. So again, what is all of this about? This is all about looking at different pieces of data, view direction, normal, world position, UVs, and all being represented in the same way, represented by color in this case. But basically, it's just the idea that with this shader, it really gives us this really unique and cool power to like take information in all different types of ways and visualize it in a way, in an artistic way. It's a really cool, like in terms of how this data is and these vectors and these numbers and all this math nerdy jargon is turning into these kind of like pretty beautiful color blends and representing data in such a seamless way. So let's actually use that now. So we've been taking a look at all these different ways to visualize this data and whatnot. Let's actually use it to its advantage somehow to create some sort of effect. Okay, so the ones we looked at were normal position and view direction. So what can we do with those? Well, there's one kind of mathy concept I want to introduce you to, which is called the dot product. So what does the dot product do? The dot product, first of all, it works with vectors. What is a vector? A vector is two things. A vector is direction, like that, and magnitude, or length, so to say. The dot product works with the direction part of a vector. So let's see, if I draw a couple cases here, if I draw a vector A that way, vector A, and then if I get a different color and go, so vector A, vector B pointing the same direction, vector A, vector B pointing perpendicular to each other, 90 degrees, and vector A, vector B pointing straight down, completely opposite. What the dot product does, it's a comparison operator. It says if you give it two vectors and they're pointing the exact same direction, it outputs 1. If they're pointing exactly 90 degrees from each other, it outputs 0. And if they're pointing exactly opposite, it outputs -1. So based off of the value of this dot product between two vectors, you can tell how alike are two vectors. Because for example, if you get a vector pointing kind of this way, will output like 0.8 kind of. You get a vector pointing like kind of down that way, will output -0.8. And so based off of this, you can kind of tell, hey, if you give me two vectors, how close are they? How closely are they related? How much are they facing the same direction? So let's take the dot product of these two guys. So if I have the normal vector and I take the dot product of this, by the way, when you enter in a node, you have these two options. You have dot product B, dot product A. Some people get confused about that. Like, hey, which one do I use? What's the difference? The only difference is there is no difference. They're both the dot product. The only difference is if you select A, then when you select it, it will attach it to the A input, versus if you select B by default, it will default to attaching it to the B input. So no difference. It just kind of auto connects it for you. So what I want to do is first give you guys some more space so we can see what's going on. And then I want to take this normal vector and the view vector and take the dot product of them and then output that. Ooh, what does this give us? All right, let's take a look. If I go back to the scene view and output, it's kind of subtle. But those of you with a keen eye will recognize that at the edges of the model, it looks a little bit darker. And in the center, it looks a lot more white. So what's going on there? I can kind of see it when I come in a little bit closer. So it has a bit of a dark tint. Well, what's going on is we're outputting the dot product, remember? And what does a dot product tell us? A dot product tells us how alike are two vectors. And the closer they are to 90 degrees apart, the closer it gets to 0. So if we are outputting, if we're taking the dot product of the normal and my view direction, which points kind of straight at me, it's hard to show you in 3D, but then the dot product out there will be 90 degrees. Whereas if the direction, normal direction is this way and the view direction is kind of towards me here, it's a little bit closer, so it'll be closer to 1. And the ones right in the middle will be straight 1, will be exactly 1. So you kind of get this nice fade effect where basically the closer you get to the edge of the model, the closer it gets to 0, because the further apart that the normal, the direction the surface is facing, and your view direction get. And yes, exactly. I see in the chat that's called Fresnel. So we're basically building our own Fresnel effect. This is a super classic effect used in shaders all the time, and it's this simple. It's just basically the dot product of the normal direction and the view direction. There is one thing I want to do to these though, just to make it a little bit more consistent. So I want to normalize these vectors. So normalizing, not to be confused with normal, is another math term. All it means is if we have a vector, remember a vector is two things. A vector is both direction and magnitude, so length, all these vectors, whatnot. What normalizing does is it says, hey, I only care about the direction. So take whatever magnitude this is, if it was all the way up here, and just make it a length of 1. So just divide it by whatever you have to, so it's only length of exactly 1. So normalizing basically just takes all these vectors, takes just the direction information, and makes normalizing, puts them all to a length of 1. That way we can compare them evenly, compare their directions evenly. So I'm going to normalize both of these vectors. Normalize, if I can spell, normalize, there it is, in 4. So I'll normalize it before I go into the dot product. Then I can just Control D to duplicate it, Command D on Mac, duplicate this, normalize this vector, put that into the dot product as well, just to give it a bit more consistency. And now when I unmaximize, go back to scene view, it still works. So we get a little bit of darkening on the edge and a little bit of white in the middle. Okay, so one thing I immediately want to do with this is I rather flip this. I rather have white on the edge and dark in the middle. So how would I go about doing that? Well, remember, these are just numbers at the end of the day. This is just a bunch of zeros at the edge and ones in the middle. So right now, the data is already between 1 to 0. So if I have a bunch of numbers, for example, on a number line here that starts out at 0 and ends at 1, and I have, for example, the value 0.2. If I want that flipped, I want that to be the opposite. I want that to be 0.8. What would that be? Well, that would just be 1 minus 0.2. And that would land me at 0.8. So if I just do that for all of my values, right? If I had all these values here and I flip them, I subtract, if I have 0.4, I go 1 minus 0.4, I get 0.6. So it's kind of the opposite. I kind of mirror it. So that's what I want to do right now. I want to take all these values and I want to just go 1 minus. So if I go subtract and I select the B version, so it just defaults it into the B channel, you can obviously change these at any point. And that's all I want to do. I want to say 1 minus all of these values. And you can already see what that's doing in the preview. That kind of flips it around. So now I started out with a Fresnel effect where it was dark on the outside and white in the middle, and now I flipped it around. So now it's white on the outside and dark in the middle. And so now we're starting to get to something that we can use. Now we're starting to get to probably a cool effect, perhaps. And you can see it's the same no matter what direction I'm looking at it from. It's always kind of white around the edge and dark directly in the center. Cool. So, careful. Okay, there we go. So what else can we do with this? Well, we probably want to control this because we probably want to have a little bit more control of how dark it is, how tight that band is. So let's keep working with it. Just let's add one more node to it. Let's add a power node to it. So what we can do with the power node is we can raise it to an exponent, essentially. So this one might be a little tricky for some people, but essentially, if we have values right now that are going from 0 to 1 linearly, if we raise it to a power, we kind of get this type of result where it kind of crunches these values down. Right? If we multiply 0.2 by 0.2, we get 0.04. We multiply 0.7 by 0.7, we get 0.49. And 0.9 by 0.9, we get 0.81. And so it still ends at 1 at the same time, 0.9 by 0.9, kind of like this. So we kind of can crunch those values and we can stay darker for longer and kind of ramp up to white right at the end. So that's what I want to do right now. I want to drag this into a power node like this. And the exponent, you can see here, as I go higher and higher, it kind of pushes that black out and keeps that white band thin on the outside. So this is pretty cool. But I probably don't want to this is like in C# when you hard code a value. If I was to just leave this here, I wouldn't really be useful to anybody on my team or designers who want to mess with this, or artists or anything like that. So what you could do is we can actually create a parameter to control this instead. So just like you create a variable in C#. So what I can do, I can maximize this. I can go to my Blackboard, can turn that on, and I have a list of properties here. And so what I can do is I can just hit the plus sign. I just want a value to go in here. This is just a single number, so we'll call this a vector1. And I'll call this the rim size, because it kind of controls the size of the rim. And now I can just drag this guy on, put him right in here, and let's default the value to 1. Maybe let's default the value to 2. That kind of gives a nicer effect by default. And save this and see what that does. So now I can go back to my scene. And if I click on my material, I have a little value here, rim size. There's my property that I can control from outside. Ooh, if I go super negative, we blow out my computer. But so maybe we don't want to do that. Maybe we don't want an artist coming in and messing things up and saying, your thing's broken, it's not working. So we can instead say, you know what, fine, let me clamp this for you. So instead of a default mode, let's change that to a slider, where I'm going to say the minimum value you can have is 0.01, because raising something to a negative power or 0 will kind of break it. And let's give it a max value of like 15 or something like that. Save the asset. And now when I turn that, start playing with this, now they can't mess it up, right? There's a super thin size, pretty much gone. There's a super low, and you can kind of find your values in between. And so now you can start to create parameters. You can play with them initially. You can kind of find the best max, the best min, and then clamp it with a little bit of a slider there. So now, oh yeah, I can show the whole shader graph for a second. You can clamp it so that now you can take a look at, you can make sure that people can kind of work with the values you expect, so to say. Keep in mind, all of this will be recorded. I'll also be uploading everything I do here to GitHub after, so you guys will have a chance to kind of take a look at things. We can even maybe open this back up during the Q&A session. So it'll be plenty of time to kind of go back over some of the stuff that I'm doing here. So now we have our control. We have this, we have the ability to kind of come in and out of this shader, or sorry, we have the ability to set a rim size, but now we want to do something a little bit more interesting. We want to maybe set a color with this guy. So now I want to introduce you to the absolute workhorse, probably the most heavily used function in all of game development, used in both C# and shaders all the time. It is the one, the only, the lerp. The lerp node is just the god of all nodes, the god of all functions in C#. We use it all the time. What is a lerp? A lerp stands for linear interpolation. Basically, if you have the number 0, you have the number 10, you have a graph, like that, 10, and you draw a line between them, right? Like that. What linear interpolation does is say, okay, if this is my A value 0, this is my B value 10, we have a T value that we control that's a 0 to 1 value. And if we set T to 0, we get 0. If we set T to 1, we get the B value, which would be 10. If we set T to 0.5, we get halfway in between 0 and 10. So halfway in between 0 and 10 is right there. That outputs 5. We get T value of 0.2, we get 20% between, which would give us 2. 0.8 would give us 8. And you can kind of see that it linear interpolates in a straight line fashion, in a linear fashion. So let's see what that looks like here. So we have the value 0, the value 1. Our T value goes between as we go 0 to 1 and kind of lerps between them and gives us the blend. So that's all well and cool, but let's see what that looks like with something cooler. Rather than just numbers like this, let's create some colors. So if I create a node, and I create a color node like this, and I plug that into my lerp, and then I duplicate it, create another color node, plug that into my lerp, and let's just create a vector 1 to control this property. So let's make the first color red, the second color blue, full blue like that. And then let's take a look at this. So now if my value is 0, I get red. My value is 1, I get blue. My value is 0.5, I get perfectly halfway in between. And everything that kind of blends between those. So now I can kind of control what color I want if I have some sort of 0 to 1 information as a mask. Wait a second. This is 0 to 1 information as a mask. So what happens if we plug, instead of plugging a single value in, we plug our mask in? Ooh, look at that. Now we have red in the middle and blue on the outside. Let's output that into the albedo. Save asset, unmaximize, go back to the scene, and look at that. Now we can kind of control, we can kind of bring some blue in or bring it out, just like that. Now, this is the point in the lesson where I will let you know I am not an artist. I am a technical artist. So I can give you all these fancy colors, but I can't give you the colors that would look good with the proper color palettes and color tones. So I let the art directors come by and do those for me. So instead of hard coding these red and blue values in there, let's change those into properties. So I'm going to convert this into a property, and we will call this main color. And I'm going to convert this one into a property as well. And we will call this rim color, like that. And so now if I save that asset and go back out here, we could have a proper artist come by and pick, they'll pick something like, maybe we'll make it just a little bit pink, kind of bring it in there. That's nice. And then for our rim color, let's make that a nice light blue, get that as a nice kind of highlight color. But that's kind of boring. So maybe instead we could set the default mode of the rim color to HDR, high dynamic range, which allows us to get some nice, spicy, emissive type of look to it. And so now we have ourselves kind of a highlight, a glow, which can be perfect for kind of highlighting something in a game where it, if you don't want something highlighted, it's kind of, well, you can make it black, it's completely off, or white, or the same color. And if you do want it highlighted, boom, there it is red. But you can kind of see either way, it doesn't really turn it off. So maybe instead we want to be able to kind of turn this off, or maybe even pulse it. Maybe, like, let's give it some life, right? This is pretty static right now. This is cool, don't get me wrong, but it doesn't really have much life to it. So how do we make our shaders animated? How do we give them life? Well, to do that, we'll take this rim color, because this is the one we want to change. Let me go back to full screen so you can kind of get a perspective. By the way, this mask is kind of done. So what we can do with this is we can select all of these, and I can right click and then group selection, and I can call this my Fresnel mask. I know it's Fresnel because I've worked with this before. Maybe you don't know it's Fresnel mask. Maybe you want to call this cool rim mask found on that one YouTube tutorial. Maybe that's what you want to call it. Cool, whatever you want to call it, so because these shaders can definitely start to get pretty hectic and crazy in node graphs and spaghetti. I'm sure you've heard of it before. So whatever kind of comment you can add to it to help remind yourself of what on earth you were doing here, all the power to you. I've seen some pretty funny comments in the industry before. So we have this rim color. How do we kind of turn this color off and on? Well, remember, color data is just that. It's just data. So what I can do with this is, these were just numbers. What happens when you multiply a number by, what happens when you multiply numbers? Well, those numbers get bigger and smaller. So let's see if we can kind of control this then. If I want to multiply this by vector 1, I can now control the output of this color. I can make this color, let's make the default of that color blue. Yeah, it is. I can make the default as, so right now it's multiplying it by 0, so I'm getting full black. But if I multiply this by 1, you can see I can kind of turn it on. And look at that, I can kind of pulse it if I bring this back and forth. Well, how do I pulse something in a shader? Well, kind of similar to how all things move. They move with time. Let's see what happens if I put time in here. So I grab a time node. You can see I have a bunch of options. I can just drag this in there. And that's probably too big because that's just regular time. So let's instead grab sine of time. Remember, sine is a function that no matter how big of an x you give it, you can just keep giving it a bigger and bigger x value, but it just keeps oscillating back and forth forever, which is kind of perfect. That's the exact behavior we need, where we can just basically put time into there and just keep oscillating it back and forth, back and forth, back and forth. So sine time is great because it kind of gives us the functionality we want there. It kind of pulses it, which is, by the way, very cool. But what we can do instead is just get a little bit more control. So I don't actually like using the sine time here. I like instead to do it myself. So if I take time and I create a multiply node first, I can now multiply time by a certain value. So I can make time 2 times faster, or half the speed. And now I'll put it into my own sine node like that. And now I basically have a bit of control over the, well, I don't need to go into that vector 1. I can just go straight into here. Now I have a little bit of control over the speed of this sine wave. So if I put this to 10, it's flashing, super fast, super quickly. Or if I put this back down to 0.5, it's very slow. Well, that seems like a perfect parameter to expose and give to a artist or the rest of our team. So let's add another parameter here called pulse speed, like that. Let's 0, we know we'll make it turn off completely, which maybe we want. No, we don't really want that. So let's maybe make the slowest speed like 0.1. Oh, wait, that's default. Let's change it to a slider. Default it to maybe 2. And let's make the slowest speed 0.1 and the fastest speed maybe 10. And then drag this on as my pulse speed, and I'll connect that into my multiply node, which again is just taking this raw time data that's just 0, 1, 2, 3, 4, 5, 6, 7, and multiplying it. So now it's 2, 4, 6, 8, 10, or if we multiply it by 10, it's 10, 20, 30, 40. So it's just increasing much faster, going into our sine, so it's captured. Now, one thing, for those of you who are keen on the what the sine graph is doing, remember when I drew that sine graph, sine actually goes like this. And this value right here is 0, which means it's going from 1 to -1. Well, we don't really want to multiply our color by -1. That's kind of doing nothing for us. We would kind of prefer if it was doing this and going between 1 and 0. So I could show you the math to do that, but given the time, I usually do it myself. I just, kind of like add and multiply and do the manipulations to the sine wave that would get you kind of put it in the range you want. But there are handy nodes out there like the remap node. So I can just call this remap node instead. And what this will do is literally what it sounds like. It will remap, if you bring in values that are in the range, in your first range, -1 to 1, it will remap it to 0 to 1. So you can remap this to whatever range you want, but we can remap it to this range right here. So -1 to 1 remapped to the 0 to 1 range. And now let's take a look at our shader creation. This is about the time you've been working for a while, and you know, maybe they're not really sure what you're doing. Maybe you took a little bit of an extra long lunch break, and you know, maybe the producer comes back to your desk and is like, Tyrell, you got that shader done yet? And you pulls this up and it's like, ooh, and all problems go away. That's quite a fun power you have over over people when you start bringing these on. Does Tyrell have a YouTube channel? I don't have a YouTube channel, but I do. I did start a Twitch channel about 3 weeks ago where I wanted to do more stuff like this and start showing you guys the development and stuff like that, going through some more things to just bring this stuff to the community. I can talk about that later, but yeah, this is a super cool thing we got right here. So rim size. We have the ability to control the size of this glow. How big is this rim? We can control the speed of it, so we can make it flash super fast, or we can make it flash super slow. Maybe we want to control a little bit more on this. Maybe we want to have the ability to, I'll show you one more quick thing. We're kind of running close to our time limit here, but let me just give you guys one little kind of fun nugget in terms of what we can work with. So right now we've been working with the albedo in this color, but there's another node that we have here called vertex position. So we can actually manipulate position from here too. So we don't need those C# programmers. We can do it all from here ourselves. We can manipulate and move things and animate objects from here as well. So let's take this, well, first let's maximize the window here. Let's take this data that we just created here and let's duplicate this. So I'm going to duplicate it by Control D, and put this up here. And I'm just going to drag time into here. And I'm going to delete this pulse speed. And I'm going to create another one, vector 1. And I will call this bob speed. Not bob as in the name, but bob as in the action, kind of a bobbing up and down action. We will change the slider to the same thing, 0.1, and maybe 10 on the speed. Make that a slider, default it to like 2, and we'll put the bob speed in here. And so how do we bob something up and down? Well, it would start out by getting the position information. So if I just type in position again and get that world position node we got before, we really only want to affect one channel. So how do we affect one channel? Well, first we got to split out the channels. So if I split them out, now I have access to the X information, the Y information, and the Z information. Remember, even though this says RGB, we have to remember what this data represents right now. Right now, this data represents the position of each vertex. So this G channel is actually my Y channel. So if I want to bob this up and down, this is the guy I got to change. So if we don't want to change these other guys, let's create a node. So let's create a combine node. So a combine node will just take a bunch of inputs and give you a vector 3 or a vector 2 or a vector 4 out of it. So I just want to, I don't want to change my X value. So I'm just going to put X into X. I don't want to change my Z values. So I'm going to put Z into Z. And then these G values are my Y channel. These are the ones I want to change. So I want to add to these guys. So I'm going to add a number to it. And then I'm going to put it right back in. And the number that I want to add to it is let's create a vector 1. And what do we add? Let's convert this to a parameter really quickly. Convert to parameter, and we will call this guy bob height, like so. And we'll keep it like that for now. Save as, unmaximize. Oh, well, we have to actually plug this in. So we have this vector 3 information. So let's plug this in straight into vertex position. So we can override the ending position of our vertices by just basically taking in the position it was at before. Now, one thing that's a little tricky is you'll notice these mention that they're an object space. So we'll just have to make sure that our position was coming in an object space as well. Just make sure that they're in the same space because these weren't working in world space. And so now if I save that and I take this bob height I can move my object up or move my object down. There you go. We don't need C# and transforms at all. I can just move this right here. And it's kind of interesting because if you take a look at this, Unity still thinks this object is here. But again, we're more powerful than Unity. As far as C# knows, it's still at 0, 0, 0. But we're talking to the GPU. We're the last line of defense. So we can make any changes we want to that object and where it's actually rendered at the final, at the end of it all. So we actually control it right here with the vertex position. So you can probably imagine what we want to do with this rather than hard coding the actual position. We already have some fancy animation data that can modify that value up and down for us. So let's take the max bob height that we want and multiply it by this up and down 0 to 1 value. So when it's at 1, it will be at the full max height. When it's at 0, it will be at 0, and kind of give us everything in between. So I'm going to multiply this by bob height, and then I'm going to plug this guy in instead to my add node. Like that. Save the asset and set bob height to maybe 5, pretty high. So let's set that to 2. And there you go. You got yourself a little kind of bobbing pickup. You could use this shader for something like, hey, this is a collectible that you want to collect in your scene. You want somebody to say, hey, teleport over here, or pick this up, or an AR, you want to highlight this object over here. Well, now, kind of in a very easy way without doing a bunch of, well, maybe not easy, but as you can kind of get close to it, easy in the sense of on your computer, you're not writing C# scripts and manipulating positions and AR and VR environments and whatnot. You can just do it right in the shader, right in the rendering, right in kind of the last layer of defense, and you can render that. Let's turn off the graph. Kind of see that. And of course, this is the material that we can add to all kinds of guys. So I can create let's create like a capsule really quickly. Bring this over here and duplicate this material, and then throw this material on there. And of course, we could change the color. So maybe you could default to white as the main color, but now the highlight color is red, and it pulses and glows strong. Boo. Let's increase that. Yeah, nice and high tone red. And let's increase that pulse speed like it's a warning, like, something bad's about to happen. Pick me up, pick me up, pick me up. That could be like a little grenade or something like that that's going to blow up if we don't pick it up in time. You can kind of do whatever you want with it. Of course, it works from any angle that you look at it from as you fly around. So yeah, that's kind of what I wanted to go over today. This would work on something like this too. We could even throw this material on an asset like this. So it would work on any model. Get the same effect. This is pretty fast. Oh, I think my computer, there we go. Doesn't like it when I click off. But yeah. So that's what I have for today. What I want to leave you guys with is a great resource for figuring out more shader ideas, and a great community to look at, and just kind of another great tool that can really show you the power that you can achieve with shaders. So if you just go to Google and you type in shader toy, you'll be met with one of the most incredible websites you've ever seen. So this is Shader Toy, and if I turn off my dark mode for a second, shaders of the week. Let's take a look at these. And what this is this is just a collection of just incredible shaders that people have created. Of course, it's not going to load for me now because we're on live. But essentially, this is a haven of shaders. What's really cool about this is you'll see a bunch of effects here that maybe I have to go back, reload. You'll see a bunch of effects here that have all kinds of, some of them have animated characters and all kinds of crazy effects and entire landscapes and environments. And all of it was created with shaders, with just graphs and UVs and manipulating white values. Like there's no actual geometry here. That's all just manipulating UVs and, sorry, not just UVs, but like white, just 0 to 1 data. And the really cool thing about these shaders is any one of them, you can just click on them and you have all the code here. Keep in mind, this is actual shader code. rather than kind of those shader graphs that we were working with. So it's definitely a little much more complex. But what's really cool about it is you can say, hey, what would happen if I change this number to 0.2? And you can re-render it. And so it's a really great learning tool for looking at these shaders and whatnot. And every single one of them comes with a little VR button. So you can just click on VR and boom, you can experience all of these, some of them super trippy shaders in VR as well. But yeah, that's my time. I'll be sticking around to answer any questions for you guys after. And oh, I think I just disconnected my webcam. Well, perfect timing. So I'll hand it back off to Steph. And yeah.
Thank you, Tyrell. That was awesome. I knew this was going to be great. Loved it. Thank you so much. Hope you all in the audience enjoyed it as well. I'm just going to toss in a poll here. I always forget, so I wanted to toss it in right now. On a scale of 0 to 10, how likely are you to recommend this workshop to someone else? Please let us know in the polls tab. It helps us know whether or not we should bring Tyrell back in for more workshops and webinars, have another shader or 3D related workshop coming up. So please let us know if you enjoyed it. Would you recommend it to someone? 10 yes, 0 no. That would be great. We would really appreciate it. So let me just share my screen here. I'm going to take about 5 minutes to wrap this up here quickly. And then we'll bring Tyrell back in for the Q&A session at the very end. So if you do have questions coming out of Tyrell's piece or anything really related to this, toss them into the questions tab. Tyrell will be back in about 5 minutes or so to help me go through those questions and answer them. So no matter what your interest is, and I know that we flew through this content quite quickly, and again, you will all have this recording to follow up with and to review on your own time. We'll send it all to you. We'll send the repo and files as well that you can work with. But if you're interested in upskilling, if this is a personal interest, a work interest, we would love to have you with us and to help you teach more about this and learn more about this. We had Mike Oakes join us in one of our programs, and now he landed a job with Unity. Jennifer Swan joined us earlier this year. She got accepted into Oculus's Launchpad program, got $30,000 of funding to continue her circuit stream project and work. And then Matt DiLallo created his own or founded his own company, Lucky VR, after taking the circuit stream course. And I do see Tyrell tossed in the chat here, his Twitch handle. So feel free to follow him there. I think Twitch might be spelled wrong, but I'm sure you guys will all figure that out. And, one thing I would like to mention here as well, Tyrell was one of our very first students here at Circuit Stream. And look where he is today, sharing the love, the knowledge. And it was a pleasure to have you with us, Tyrell. Thank you very much. So for those of you who are really, looking to dive deeper into the 3D art, the shading side of things, we actually have a specific course designed for this, our 3D Art Foundations in Unity course. I believe Tyrell will be teaching this course here. So if you are looking to dive deeper into the artistic side of things, the shading, the effects, feel free to check out this course here. We'd love to have you with us. Tyrell will be the teacher and instructor here, so he'll be sharing more wisdom nuggets with you all. It's 3 hours of class per week over 6 weeks, and the next course starts on January 5th. Now, we do also have our flagship program, the one we've been holding for the last 5 years, our XR Development with Unity course. For those complete beginners, those who might not be as familiar with Unity, C#, the shading, and the effects, this course is for you. 10 weeks long, 4 hours per week, and our next course is set to begin on February 15th. Now, what you can learn out of this course, well, using Unity to make VR and AR projects and applications, the fundamentals of C# coding, and again, 3 hours of class plus 1 hour private session over 10 weeks to help build out your own idea and project together. Now, there's no experience required for this course, so newbies, have no fear. We welcome everyone from all walks of life and help really build out your interests and dreams there. Now, for those of you who are like, Steph, I took your course, or I'm already familiar with Unity, I've created my own projects, we have a advanced course, our XR Project Accelerator program, to really take you to the next level, polish up your projects, your applications, really into something that you can commercialize or use at the very end here. This is 8 weeks long, 6 hours per week, 3 in class, 3 hours of private sessions with guys like Tyrell or our other instructors and teachers. Now, for these two courses, the 10-week and the 8-week, the beginner-friendly advanced one, we have payment plans and financing options available from 3-month to 6-month and 12-month payment plans if interested. Now, if you have a team, group of colleagues, members really looking to learn together, create your projects together, we have team trainings available as well. It's live and online as well. Custom schedule depending on your team and work, or content created from our catalog or something custom that you would like to be taught about. Now, again, similar to the 3D art course that I mentioned earlier, we have a bunch of different individual courses from Unreal to the Oculus Quest to the HoloLens, you name it, we've probably created it. So check it out on our website, circuitstream.com/learning. Now, some of you may be here. I did pitch these courses, but we still have our Black Friday promotion and special going on for our 10-week beginner-friendly course, a C# short course to help you prepare for it, and an Oculus Quest 2 brought down to $3,000, also available with the payment plans. Now we have our advanced XR pack for those who are already experienced in this, our 8-week XR project accelerator course, C# course just to help you get familiar with this again, and an Oculus Quest 2 headset for $3,500. Payment plans available here as well. Now, we also have a third bundle, 30% off of any course that you would like to attend, and that includes the 3D art course that Tyrell will be teaching and leading in the new year. So if you're interested in any of those, feel free to check out our Black Friday promo on our website. It's open and available until Tuesday next week, but no rush, okay? Just let us know. We're happy to work with you, but these are available currently. You may speak to myself, to my colleague Kyle or Vlad that you've seen in the chat here. They'd be more than happy to help alongside myself. Again, circuitstream.com/learning if you're interested. But with this, I would like to slowly re-invite Tyrell back onto the stage here. I know we have some questions in the questions tab that were left unanswered, and then we'll get chipping away at those. So let's just bring this back here. Get it back. Beautiful. Hey, Tyrell. Good seeing you. Good seeing you.
Good being here.
Perfect.
So we could just start rolling through some of these questions. I saw one from Ricardo. Why would you change the position of an object through shaders? Is it more performant? It can be. One thing you definitely have to be careful with about shaders is they can be very expensive if you're not careful, because remember, this is running per pixel. So every single color that you write, every single piece of like all that, the shader code that we wrote is running for every pixel because it has to be calculated, which means if you have a 1920 by 1080 screen, that's some million odd pixels, which means that's basically like a for loop, like an update loop that's running for each one of those. So you definitely got to be careful about how much stuff you throw into a shader. The shader instructions is usually the count that we use to keep track of that. But as long as the shader instructions stay low, and you're not doing any kind of too much crazy operations being square roots, which can be super challenging for computers, since it's not that smart. It just kind of keeps on doing a bunch of if statements until it gets there. But as long as you're not doing anything too crazy, yeah, position changes and shaders can be super nice. One of the reasons why you might do them is to achieve an effect. For example, on particle systems, a lot of times I've spent a bunch of time in Unreal working on AAA games, and what we did in there all the time is I'm always working on shaders and particle effects. Shaders and particle effects, they go hand in hand to create really cool effects. And one of the things is you can't really talk to individual particles that easy sometimes, or maybe you're already doing something super complex. So maybe you want to just throw a shader on there to give that extra little bit of motion, maybe a flag wave, because you have much more individualistic control. One thing you might not do is move an object in total, the entire object with a shader, but what you can do is move the individual vertices of a shader and give some really cool motion and distortion waves like that, because you have control over the individual pixels, so you can move those around individually. That's where you'd want to get into that. I've actually If I share my screen for a quick second, I got this up and running. This is like the gold standard of shaders on ShaderToy. This water right up here. That's why you would want to use a shader for motion, because that's just one plane with a bunch of vertices. In fact, this one isn't because it's on ShaderToy, but all of that can be animated with a shader with nice sine wave motions and stuff like that. Keep in mind, this is the other thing I was talking about, that animated character, all completely just a shader. Isn't a single model in there. Also not a single model here. All of that's pretty insane. But yeah, I'll keep going through some more questions here. I saw a super simple one, which was what program am I using to do the screen to draw on the screen? That's just Lightshot. That's an awesome program. One of the best things about Lightshot isn't even the drawing on the screen. It's you just press the print screen button and you can instantly like create that window like I was creating, and you can just Control C and you can paste that screenshot into any application. You can paste it into Slack, paste it into Google Chrome, paste it into wherever. So you don't have to do that whole print screen, go into Paint, snip it out, crop it, all of that. You can also Control S to save it right away. But I've been using it a lot recently to do what I just did and just very quickly start drawing on the screen, because you can also mark it up. So that's super handy. Back to some shader questions. Why would we implement, can we implement ray marching with SDF effects and shader graph? So what that is that's the techniques that they actually use, ray marching and SDF sign distance functions. That's what they're using to actually create all of these cubes and models that you guys were seeing on that. It uses a tech called ray marching, which is, could I explain that quickly? Maybe not. That would probably be a little long. But essentially, it's a technique of just shooting an array and doing some calculations to basically determine, should we start drawing something or should we not? That's the simplest explanation I can give you. And essentially, we can basically create we can create curved lines and models and make it look like we give effects, especially when we add lighting and everything to it. And yes, you can, because at the end of the day, sign distance functions and ray marching is just, it's just math. It's just being very clever with the floats that you output into the albedo and using math to do that, essentially. So there's nothing stopping you from writing that math inside shader graph. You can even create custom nodes where you can create your own regular HLSL and just code it away. And you can go to ShaderToy and take a lot of the HLSL. Well, they have GLSL, but similar enough. You can take a lot of the code they have there and implement that in a custom node inside shader graph. And so, yeah, you could have a lot of ray marching in there as well. I haven't actually seen a good example or a practical example of ray marching in games yet, or actual applications. It's still just kind of like a really cool thing that you can do. I haven't seen somebody try it. Although I'm trying to think, there was an effect. I think I got close to using it inside of one effect I was doing at the last game I was working on. I got very close, but then we went a different direction, unfortunately. But I almost did it. What are some other questions here?
So there's one here from Pavel,
Yep.
kind of stemming off of the ShaderToy. So he's asking how to make a shader from ShaderToy website pop up on the Oculus Rift S if he has it connected, if you know.
So you need to use WebVR. Chrome doesn't have it by default, but Firefox does.
Right.
So nobody uses Firefox by default, but we use it when we want to use WebVR. So that's why I have it installed. And so if you launch up Firefox and your Oculus Rift is connected, then when you click that VR button, it should prompt you to say, hey, enable WebVR, and then boom, you'll be able to experience all that shader goodness in virtual reality, which I have done and is quite cool, especially how it just works, which is also pretty insane.
Right.
Smarter people than you and I made that. So
then there was one here from Jonathan, and this was when you were talking about the code and you're like, we don't need the C# and whatnot, but he's new to Unity and he was wondering if it's possible to alter the properties in code, something like.
Yes, exactly. And that's actually very handy. One of the reasons why we expose those properties. So if I share my screen really quickly. So if we go back to Unity, and go into this shader. So these properties that we have right here, these are just for interacting with the inspector. But in order to interact with it in C#, it's actually this reference thing, which is super ugly. So we probably want to change these names because we're never going to remember vector 133 EA7DE, right? So what we can do is we can change this to the typical kind of naming convention is just underscore and then the same name. All concatenated like that. So this would be the shader property, and then you'd be able to go into C# and you'll be able to get component mesh renderer like that, dot material, and then dot set property, I believe is the function you would call, and you'd be able to pass in the name of that property like so. It might actually be set float property or set float parameter. You'll see it if you just go dot, and it will pop up on the in Visual Studio Code completion. Then you can set that to whatever value you want. So now you can create your effect in shader graph, and then you can start talking to it. And that's where you can get really powerful, is when you start combining the power of C# scripting with the power of shaders. And now you're talking to those shaders in the back end. And that's when you start making the big bucks in AAA, because that's when you can start making some really cool in-game effects.
Perfect. Right on, right on. And then, and this was during the time you were talking about the sign and the sign time. And Ricardo was wondering, is it the same if they use, or he uses, sign time in the time graph?
So that's what I was explaining in terms of sign time in the time graph is the same as if pulse speed was set to 1. Right. So that's the only reason I don't like just using this, because if we use this works completely fine, and we get our pulse effect. But then we can't control the speed of it, because I like in Unreal, when you use sign time, usually when I click on this, I would have some properties I can change on here maybe, but they don't expose them to me. So I can't make this sign pulse any slower or faster. So that's just why I separated it out. I just added it into a multiply node first, and then I threw it into the sign. So that way I can control the speed of that time. So I can make it the sine wave faster or slower. So that's the only reason I separated it out. But the regular one does work fine.
That makes sense. Perfect.
Hi, my main preview of the shader is not displaying anything I can do. Restart. Probably turn it off and turn it on again. The best technical solution in the history of technology. Turning this on. The other thing that could be the case is if I go to maximize, I'm pretty sure I can move this around, and I think I could even scale this up and down. So it might be hiding somewhere off screen. Doesn't look like I can make this off screen, but yeah, I'd probably restart or reset your layout to default settings, just to try to reset this guy, because this should be showing up. But it could be a version issue. Make sure that if you go to the package manager as well, that you have the latest recommended version of shader graph installed. If I go to Unity registry and go to my shader graph, I'm on 8.2. You can see there are, actually, it's disabled right now to look at other versions. But there are more versions, like a 9.0, which I was playing around with a little bit earlier. It's a little bit buggy still. So I'd recommend staying on 8.2 if you're on 2020. So they'll make sure you're just on the green checkmark version based off of the version of Unity you're in, which could be changing things.
Mm-hmm.
My circle preview in the shader window is pink. Yes, the pink color of death, as we like to call it in shaders, because that pink color of death is the indication that something is wrong, something is broken, there's an error. Basically, if I don't even know if I can create it in the shader like this, but I know. If I unmaximize and I take a look at this guy and I delete his material like that, he turns pink, which is basically the signifier. The reason they use pink is because this is an extremely unnatural color. You will be hard pressed to ever find this color inside of reality, which means if you see this color in your game, chances are something's wrong. So this is kind of the indication of an error. Basically right now, this error is that it's literally missing a it's literally missing a material. So they do the same thing if the shader has an error in it. So the error that you're most likely getting based off of some of the stuff that I had you do is if you throw in, for example, a negative value into this power. So if I say rim color, I think if I, wait, where's, oh, rim size. This value right here. I think if I get rid of the slider and go -2, no, that didn't do it. One of these guys would do it. If, oh, negative values are coming in here. Yeah, there we go. That would give you some problems. So doing things like making sure that you normalize your vectors first, because if you don't normalize them, then these vectors can be a lot bigger and smaller, and you could get dot product values that are negative, or dot product values that are bigger than 1. And when they're bigger than 1 and we subtract them from 1, you'll get a negative value, and then you'll get this pink. So I would recommend normalizing, making sure your vectors are normalized first. The pink doesn't really matter if when you go to the game, it never shows up pink, but it can be annoying if your preview isn't matching what you kind of want to see, because these preview windows can definitely be quite handy and helpful for like keeping track of what's going on in your shader at that point in time.
Beauty. Yeah, I thought that was a similar issue. When I started working with Unity, saw a lot of pink
everywhere. Yeah. The other thing you'll get pink for is if you have a regular project. So I started this project in URP. When I created a new project, I selected the universal render pipeline as a default. But if you have a regular Unity project that isn't on that pipeline, and you go to the window package manager and you install the universal render pipeline, one of these guys, URP, then most likely a lot of your shaders will start out pink. That's because, as I was mentioning, when you create a shader by default in Unity, in the standard render pipeline, they are these surface shaders, which do not work in the new one. So because they do not work, you get an error. And remember, the error color of a shader is pink. So in order to fix that, you just have to go to your edit, render pipeline, and universal render pipeline, and select upgrade project materials to URP. And that will do its best to convert any standard surface shaders to the new URP style of shaders. So that should get rid of any pink shaders for you if you convert a project that didn't used to be URP to URP. Right. That's a super annoying problem for a lot of people when they move to this pipeline.
Perfect.
Do you need powerful GPU to work on shaders in the high end? Obviously, yeah, but I mean, yeah, obviously, yeah, but it's kind of the more you want to do, the more graphics power you need. But also keep in mind, how much do you want to do that's just for yourself, right? Most of the time when we create these projects, we have a plan of giving it out to the world and showing them. So it's less about the hardware we use and more about the hardware that we're deploying to that we want to keep in mind. So often in game studios, they don't even give us the best computers, because it's like, hey, if I give you a 2080, you're going to make code that, you know, runs on a 2080. So we're going to give you a we're going to give you a lower end version. So you'll get used to making it work on this. So when you do deploy it to all these gaming PCs, it will run super smoothly. So keeping that in mind, that it can be a bit of a mental trick that maybe you don't actually want to be working on a super high end GPU, just so that you can get used to making it work on some lower end hardware. That way, when you do deploy, it runs super smoothly on everybody else's machine.
That's a great point, Tyrell. I actually never thought about that. You know, you work with something strong, you build something strong, and no one can use it, right?
Exactly.
Oh, nice.
I'm going to butcher the statement, but it's something like producers always say, like programmers will expand to the amount of time allotted for them. And it's same thing with performance. Like if we feel we have this many frames to play with, we will hit that max amount of frames, especially with artists as well, right? If you tell them, hey, our game's doing great, next morning you'll see a model with, you know, an extra 5,000 polygons or something like that. So yeah, definitely keeping them reined in, so to say, with the hardware that we're working on can definitely help making sure that it stays performant for everybody else.
Right. Perfect. And then looks like we only have one more question here in the questions tab. So feel free to toss in some more if there's any out there. But this one's from Hyun-sang. And kind of maybe outside of this, but what are the limitations on a mobile platform, including VR devices such as Quest 2? Also, any differences with those?
Unity will generally do a pretty good job in the of letting you know when you've hit those limitations. whoops, not preferences. I want to go to edit project settings. So in the project settings, if you go to player, you'll actually see the graphics API that you're working with. So right now it's set to auto. For me, if I turn that off, then you can actually select it. So you can see I'm working with Direct3D 11, DirectX 11. You can add DirectX 12, and basically this kind of graphics API is what would specify what shader functions and stuff like that you're actually able to use. So when you click on Android, which is what the Oculus Quest would be using, it actually defaults to adding the Vulkan API, which you actually can't use. Vulkan API is a newer, kind of cleaner, faster graphics API, but it doesn't actually work on the Oculus. So already Unity will give you an error, or it won't work if you try to build with this. So already to build to Oculus, you're going to have to kill that one and only work through here. So when this is your graphics API, when you go to your file, build settings, and switch your platform to Android, Unity will give you an error if you're using apparently my Quest just connected or disconnected as we were talking about Quest. Spooky.
Right.
I was saying, so when you switch your platform to the one you're working with, then in here in your player settings, it will set your graphics API to that. So if you start using a shader function that is outside of that API, it will let you know with the pink color of death. But of course, always testing on the machine as well. You'll see it's kind of hard to get a complete list of the things that work and don't work because, they're always adding new functions and stuff like that. But for the most part, most effects that you're doing will work on the vast majority of shaders. It's only when you start getting really experimental or really fancy where you might run into a property that doesn't quite work. I think it would actually be quite hard to run into that in the shader graph because most of these nodes are just pretty standard things. That'd be more for if you're running into your own shader code and you're adding a bunch of fancy things where you might run into something that's not supported. So that's why when you do look at the default shaders, if you were to dare, if you had the courage to take a look at the shader code that is generated from this guy and take a look at that monstrosity, it would you'll actually see a whole bunch of scripting defines at the top that basically say if it's this version, if this is this shader model, if it's this, and basically that all those if statements and all those shader model says shader model 4.0, shader model 3.0, if it's DirectX 3, if it's Xbox, if it's PlayStation, it will have a whole bunch of those defines for lines and lines that basically are the kind of guard code to guard exactly against that. To say, okay, if it's this, I can only do this. If it's this, I can only do that. Stuff like that. Is working with shaders GPU intensive? It is purely GPU work. Yeah. So as I was saying, shaders are programs that run on the GPU. So no CPU is involved really at all, depending on, I guess, if you're sending properties to it at runtime with the C#. But for the most part, shaders are GPU programs. So it's purely a parallel GPU program process.
Awesome. So I think that might be all the questions that we had here in the questions tab that were left unanswered. If there's anything else, feel free to toss them in the next minute or so. But, with this, Tyrell, the man, the legend, thank you so much for joining me today on this workshop and webinar. Really appreciate it. I loved it. I knew it was going to be amazing. To everyone who joined us from all over the world, thank you so much for tuning in. For those in the U.S., happy Thanksgiving. Go eat some turkeys.
Indeed.
And again, this will be recorded, sent out to everyone to follow along if we were going too quick. Feel free to join us on any future workshops and webinars. We would love to see you there. Take a look at our courses if those are of interest to you. And as always, the whole team, myself, Tyrell, Dayon, Kyle, Vlad in the background, anyone is here to help you all with anything that you may need to know or have any questions about. So with this, doesn't look like there are any more questions in the questions tab. Timbo, no problem. Ricardo, thanks for joining. I guess we'll wrap it up here slowly. So Tyrell, thank you again. Really appreciated it. Everyone who joined us today, have a wonderful evening, a great night, a great morning, depending on where you are. A wonderful weekend that's coming up. And again, we all thank you for coming and hope to hear from you soon and see you on future workshops. Take care and have a good night.